Welcome to this explainer. Today, we're diving straight into a frankly urgent, incredibly fascinating tension that's popping up right at the very edge of human discovery. We're talking about the explosive, unignorable rise of generative AI in scientific research. Look, on an individual level, AI is completely supercharging productivity. It's helping scientists write, code, and crunch data faster than we ever thought possible. But beneath all those massive individual gains, there are these hidden systemic risks. Risks that could, quite literally, threaten the integrity of our collective scientific knowledge. So, let's just get right into it.
Take a look at this number, 1 in 277. In early 2026, an audit looked at over 2.5 million medical papers, and they found that 1 out of every 277 papers contained a completely fabricated reference. That is a massive, frankly alarming spike from just a few years prior in 2023. And we're not talking about innocent typos here. We're talking about AI hallucinations making their way into the permanent peer-reviewed medical record. The stakes for human health and just baseline scientific truth are incredibly high.
And that brings us to the core mystery we're unraveling today. Is AI actually making scientists smarter? Is it pushing the boundaries of what we know? Or is it just making them faster at producing noise? Are these massive individual gains in speed and volume actually causing collective harm to the scientific community as a whole?
Okay, here's our roadmap for how we're going to break this down today. We'll cover the AI science boom, the hidden collective risks, 3 mechanisms of divergence, the RRAI framework, 4 principles of governance, and finally, saving the scientific frontier.
All right, Section 1, the AI science boom. Let's validate some of the hype here.
Because AI really is fundamentally transforming research. And the individual benefits on the left side here, they are absolutely staggering. Large language models are drafting manuscripts, they're debugging complex code, they're synthesizing mountains of literature. This is driving publication volume up by as much as 89.3%. AI-assisted work is also grabbing a significantly larger share of citations. But check out the right side. When you zoom out, the novelty and the disruption of these papers, totally flat. We're actually seeing a 4.63% drop in topic diversity, alongside a 22% drop in engagement between scientists. So basically, people are publishing way more, but they are exploring way less.
Moving on to Section 2, the hidden collective risks. Let's talk about the invisible tax.
This invisible tax is quietly being levied on the entire scientific community. And one of the most dangerous effects is this homogenization feedback loop. Here's how it plays out. AI models are trained on existing literature, right? So naturally, they encode the current scientific patterns and conventions. A researcher then uses that AI, which spits out those exact same patterns. The researcher publishes that AI-assisted paper, and then, here's the kicker, that new paper becomes the training data for the next generation of AI models. It creates this technical phenomenon known as model collapse. Science literally loses its diversity. It converges only on the most computationally easy questions, and we end up leaving the data sparse but incredibly vital real-world problems totally behind. Researchers Masseri and Crockett actually put this perfectly. They noted that AI creates illusions of understanding. Just think about that for a second. The struggle, the friction of reading and coding and synthesizing, that friction is usually how a scientist figures out what they don't know. By completely removing that friction, AI makes researchers feel like they totally comprehend a domain when really they might just be gliding over the surface. And in fields like medicine or structural engineering, an illusion of understanding isn't just some abstract academic problem. It can lead to catastrophic real-world disasters.
Let's jump into Section 3, 3 mechanisms of divergence, why private and social returns are splitting.
So, why exactly do these private gains diverge from the social good? Well, to get it, we really have to look at the day-to-day reality of a working scientist. The whole research ecosystem basically operates in 4 main stages. First, you've got funding, writing and evaluating proposals. Second, research tasks, the actual grunt work in the lab, coding, and synthesis. Third, publication and peer review, where your work is judged by peers. And finally, use and uptake, where the real world actually takes this knowledge and applies it. Generative AI is currently disrupting every single one of these stages, all at the exact same time.
And across those 4 stages, there are 3 distinct mechanisms causing this collective harm. First up is information asymmetry. Look, if a hiring committee or a grant panel literally cannot tell human output from AI output, they can't accurately predict that researcher's future capabilities. Think of it like sports doping. We care about where the insight came from because it tells us what the unaided human brain can do next.
Second, externalities on shared resources. This is that homogenization loop we just talked about. It degrades our shared knowledge base, and ironically, it might actually make funders slash research budgets if they falsely assume AI has made the labor dirt cheap. And third, capacity depletion. AI is basically absorbing the exact struggles, the debugging, the drafting, the synthesizing, that early career researchers desperately need to go through to actually build true scientific capability.
Okay, Section 4, the RRAI framework. This is where responsible research comes in.
Now, this blueprint is absolutely brilliant. It maps out the entire problem and the proposed solution in complete detail. So let's really walk through this. At the very top layer, you see those 4 stages of the research process we just laid out: funding, research tasks, publication, and use. Now, looking at the second layer, it highlights the undeniable reality. AI adoption raises private returns at every single one of those stages. Everyone is getting faster, for sure. But follow the arrows down to the third layer, the mechanisms of divergence. This is where the framework separates out the risks we just covered. Box 1 identifies information asymmetry. We can't tell human from machine. Box 2 identifies externalities, that epistemic homogenization and the fiscal risks to public budgets. And Box 3 identifies capacity depletion, AI eating up the learning process. Now, this is the really cool part. Follow those arrows down one last time to the fourth layer. This is the core of RRAI. It maps every specific problem to a specific governing principle. To solve information asymmetry, we apply Principle 1, disclosure, at the informational level, which has to be tiered by risk. To solve the fiscal externality, we need Principle 2, narrative at the communicative level. This means fundamentally changing how we measure scientific progress so we aren't tricked by just sheer AI-inflated volume. To solve capacity depletion, we use Principle 3, differentiation at the pedagogical level. This ensures doctoral students still learn the hard way before they're allowed to use the AI shortcut. And finally, sitting at the very bottom, supporting this entire structure, is Principle 4, proportionality at the distributional level. This simply ensures that the costs of complying with all these new rules don't end up completely crushing smaller, under-resourced institutions. It is a fully, beautifully integrated system.
So let's look closer at those rules in Section 5, 4 Principles of Governance. How do we take these big theoretical concepts and actually apply them? Here's the rundown. Disclosure means we need mandatory standardized tracking, but, and this is key, it must be tiered by risk. Differentiation means universities actually have to create schedules dictating exactly when a doctoral student is allowed to hand off tasks to an AI just to protect their learning curve. Narrative means redefining what a successful scientist even looks like. If we just count the number of published papers, the AI wins every time. We have to start valuing things like data sharing and actual real-world impact. And proportionality? That means the massive, wealthy publishers and institutions need to foot the bill for all this administrative infrastructure, so compliance doesn't lock out researchers in the Global South.
This table charts out the specific tensions of this whole debate perfectly. Let's break it down row by row. In the domain of selection, the pro-AI argument is pretty straightforward. Output quality is all that matters. But the governance concern is that evaluators lose their ability to predict a scientist's future, human capability. So the RAI response resolves this with tiered, mandatory disclosure. Next, looking at workload. The advocates say, hey, AI frees up time for deep conceptual thinking. But the governance concern is that an absolute explosion of AI-generated papers actually drastically increases the verification workload for everybody else. It just clogs the system. The RAI response here is to require funder statements that explicitly limit what they infer from sheer publication volume. And finally, regarding training, the pro-AI case leans heavily on the old calculator analogy. We adapted to calculators will adapt to AI. But the governance concern is that calculators automated procedure. AI automates substance, completely short-circuiting actual substantive learning. So the RAI response is career stage delegation. Think of it like forcing a student to write pseudocode to prove they understand the logic before letting the AI generate the functional code.
And what's great is that the RRAI framework isn't just theory, it's an actionable scaffolding. This table maps exactly who does what at every single stage. During funding, the governing principle of disclosure means research councils are the ones who must require AI use declarations right there in the grant proposals. Moving to research tasks, the principle of differentiation means doctoral programs are the actors tasked with implementing verification seminars. When we get to publication, proportionality means the publishers themselves must take on the burden of providing machine-readable disclosure templates, making it easy and free for the authors. And in the final uptake stage, assessment bodies have to step up and change the narrative by officially weighting non-inflatable indicators, like whether the code and data are actually available over simple paper counts. Every actor has a very specific job to do. I really want to emphasize one vital point of clarification here, and that's how we handle disclosure. A simple binary checkbox that just asks, did you use AI, yes or no, is completely, wildly inadequate. The framework demands tiered disclosure based strictly on the risk of an undetected error. So using an AI to polish up your grammar, that's low tier. It just requires a simple declaration. But using AI to synthesize a massive literature review or generate core data analysis, that's high tier, because an error there literally poisons the scientific record. Therefore, high tier use requires full mandatory documentation and complete audit logs. Not all AI use is equal, and our governance absolutely has to reflect that reality. All right, final section. Section 6, Saving the Scientific Frontier.
We really need to zoom out and look at the ultimate stakes here. The debate right now is so often framed as this rigid binary. Either we allow total, unrestricted AI adoption and let chaos reign, or we impose these draconian top-down regulations that totally stifle innovation. But guys, that is a false dichotomy. The real choice is whether we are willing to step up and design deliberate, nuanced instruments, like tiered disclosure and career stage delegation, that preserve all those incredible individual productivity gains while actively, smartly managing the invisible collective risks.
Look, we have an incredibly powerful new tool in our hands. The decisions we make right now about how we govern it, they're going to shape the entire future of human discovery. So it all really comes down to this one question. Will we use AI to genuinely expand the boundaries of human knowledge? Or are we just going to use it to automate our own illusions of understanding? Thank you so much for joining me on this explainer, and as always, keep asking the big questions.